Hello everyone, we are going to be solving daily Leetcode problem 3363, find the maximum number of fruits collected. Before starting this problem, we shall have a small motivational quote. Just as iron is weakened and destroyed by its own rust, a person's greatest downfall often comes from their own negative thoughts and self-doubt. Your mind has the power to build you up or break you down. Fear, overthinking, and self sabotage can erode your confidence and potential. But by mastering your mindset, you can protect yourself from inner destruction and turn challenges into strength. The real battle is within. Guard your thoughts, for they shape your reality, right? So your thoughts is what shapes your reality. So do not overthink or do not overstress on certain things. Just stay in the present moment. Keep working hard. This is an hard type problem. This is an hard type problem. There is a game dungeon comprised of n comma n rooms arranged in a grid. You are given 2D array fruits of size n comma n, where fruits of ij represents the number of fruits in the room ij. Three children will play the game. Initially, one children starts at 0 comma 0, or the starting top left cell, and the other one starts from top right cell, that is 0 n minus 1, and the last one starts at bottom left cell. Children will make exactly n minus 1 moves according to the following rules. So n minus 1 moves will be there for each children to reach the ending room. N minus 1, n minus 1. The child starting from 0 comma 0 must move from their current room ij to exactly I plus 1 j plus 1, or I plus 1 j I j plus 1 to if the target room exists. And the one on the right side will move I plus 1 j minus 1 and I plus 1 j minus 2. Children starting at left bottom cell will move in I minus 1 j plus 1, I j plus 1, I plus 1 j plus 1 if the target room exists. When a child enters a room, they will collect all the fruits there. If two or more children enter the same room, only one will collect the fruits, and the room will be emptied after they leave. Return the maximum number of fruits the children can collect from the dungeon. So, in order to understand what this path means, so let's say we have this kind of an array, and we should already understand that there is this child 1 starting here, and there is a child 2 starting here, and also child 3 starting here. This guy will move in this direction, and this is the target room. This is the target room, and this guy can either move this way and this way, and this guy can move this way, right? And the total number of moves that each child gets is n minus 1. That being said, let's understand this problem better through this example. So let's say we are given with such an array. The first child goes through this path, and he collects all these cells. The second child goes from 0 3 and 1 2 and 2 3 and 3 3. This is the path that he takes. The third child takes a path where he goes this direction, and he goes 3 2 and 3 3, or 3 3, right? So these are the set of paths that this guy takes. So let's say 0 0 1 2 3 1 2 3 3 1 and 3 2 and 3 3. So this is the path. He goes this direction. Sorry for that. He doesn't go in this direction. He takes all of these these steps. Whereas this guy, he goes uh, 0 comma 3. This guy goes 1 to 2. He goes 1 to 2 and 2 to 3, 2 to 3 and 3 to 3. So I was a bit wrong here. So let me redraw all of these. So we are clear that let me use three different markers. So the first child goes in this direction. This will be child 1, whereas child 2 takes a path 0 3 to 1 2, 1 2 to 2 3 and 2 3 to this direction. So total number of moves is, this is the first move, second move and third move. So there are only 3 moves that each child can take. So this is one move, second move and third move, right? And finally the third child uh, moves in this direction. So he moves to 3 1, 3 1 to 3 2 and 3 3. So it's a straight path. 1 2 3. Okay. So got it. Let's see. And these are the total fruits that he collects. 100 fruits. I would not go through the example 2. I will directly move to the solution approach that we are going to take for this problem. So we know that there are three children. The first child can obviously go through the diagonal path. The second child would take a different route. Uh, the one that starts from the top rightmost corner, and the other one, the child third, that starts from bottom leftmost corner. So they both have a bit different stage, but our approach will be, firstly we collect all the fruits with child 1. This would be a simple one where we traverse through I comma I array and we collect all the fruits there. And next, for child 2 and child 3, we start writing certain things like we initialize right path of 0, let's say fruits of 0 and n minus 1. And similarly, bottom path, let's call this bottom path for the child 3, and he starts from fruits n minus 1 to 0, right? So this guy starts from top right corner and this guy starts from bottom right corner. That's what we know. And we use dp expansion. So we use dp expansion. So we iterate over the steps from diagonal to the arms. So now, in order for us to calculate the right and bottom paths that we were talking here, so we shall have a for loop where we iterate through steps from 1 to n minus 1 and step plus plus. And for each step, we will keep track of all the values or the fruits in a new right array and new bottom right array. And next we will keep track of a distance is less than window distance plus plus. And here for each of the directions with respect to the cells, I will redraw whatever we had here. So this might almost follow the diagonal path, so something like this, and in this way. So we either need to move diagonally. This would be 1, 2, and 3. Let's say 0, 1, 2, 3, 4. So 1, 2, 3, 4. So yeah, so just to redraw what I have here, let's say we have uh, so we know that child 1 is something that goes directly, and these are two childs that would almost come close to the diagonal path, and then from there it takes its course. So we also know that there will only be three paths, so we move this direction, and we move this direction, and then from here we move to, this would be one path, from here to here one path, and here to here the third. So the best optimal path would be this way, and this way 2 and 3. This would be the path. Similarly, in the opposite way, um, we go here as the one path, and this as the second path, and this as the third path. These are the three arms. So we are almost having to get back to the diagonal path. So the way that we do this is, let's say we try to steer our child 2 or child 3 such that we either move left, right, or in the same direction. So for that, let's say for right path, this would be our some if we have to move, so this will come back to the right path, and then this way. So this will be the way, so to move left, and if we will have to move to the right, then we will, if we will have to continue in the same path, then we will use this, which will be one greater, and we move in the same direction. And similarly for the right path, I hope you can guess it, just like this one, we add up one, and if it's less than one, then we increase right path with distance plus one. So that's what we do. I will add in the code snippets, and I hope you can relate to the code. Okay, so let me start adding in the code. So this should complete the path that we were looking for the child one. Now it's time for us to move to the child 2 and child 3, which would take up right path and the bottom path. So we are defining the window is equals to 2, and we are also saying these are the two possible outcomes starting from new right and new bottom, right? So now we come to the core TP for. Once we have calculated the right value, now we also calculate for the bottom left child 3. Okay, once we have both the. Okay, so this should solve the problem. Let me try submitting it. Okay, let's see if this works now. As you can see, the solution gets submitted. The main crucial part here is to understand this piece of logic, which helps us move in the left, right, or middle, or in the same direction. So that's something that is a crucial piece to understand. The rest other things can be understood easily. Hope you found this video helpful. The time complexity of the solution would be O of n square, as we have two nested for loops, and space complexity would be O of n, as we have the right path and bottom path being tracked. Right? Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.